Hey, hi everyone. Welcome to CodeTav Management, Hadoop playlist. In the last video, we have discussed about the basic Hadoop introduction. So now, in this lecture, I will mainly cover the Hadoop architecture, how the internal workings are happening. Those things I will cover in this lecture. Okay. So let's start. So first of all, see, like what is Hadoop? I have told, but again, I am just telling. Hadoop is basically an open source Java framework that stores and processes massive data. Massive data means the size will be like petabyte, okay, or more than that. So, using some clusters of inexpensive or like your commodity hardware. Okay, that's the case. So, based on Google's MapReduce programming model, it enables distributed and parallel processing, right? So, big companies, like the Facebook, Yahoo, Netflix, eBay, they mainly use the Hadoop to handle the large scale data efficiently and promptly. So the components in the last lecture also I have discussed. The first one is a MapReduce for the distributed processing. Next, the HDFS, Hadoop Distributed File System for your distributed storage. Next is your yet another resource negotiator that is specifically for your job scheduling and the resource manager. And next is your common utilities. They are like it is also known as the Hadoop common. So it is basically the Java library and the utility. It is wherever you will write some scripts or all. And then like one by one, if you will see, the first one is MapReduce. So the MapReduce, I have told you that it is the data processing model in Hadoop, right? So that basically runs on Yarn, yet another resource negotiator. Okay. So here you can see this big data input is there, and from that, after getting the input, the small chunks will be done via this map, and then the reduce through the reducing we will compile them with our required one, and we will make our output to the user. Okay, so how the thing is happening, like the large scales, like it how the firstness comes, like how it enables the first distributed and parallel processing. So that basically done via this MapReduce. So that dividing the tasks into two phases. One is the map, another one is the reduce. You can see from this picture, right? And it making it efficient for handling large scale data actually. So I will tell you about this MapReduce workflow. So workflow begins when input data is split into key value pairs by this map function. These are then grouped by key and processed by reduce function for tasks like sorting and or aggregations, and then the final output is written to the HDFS. Okay, so how the thing is happening? So see the map task components. The first one is record reader. So what record reader do? So record reader basically reads the input data and converts it into key value pairs, and with keys as location info and values as actual data. Okay, so through the keys it actually located them, and through in the values the actual data will be there. So record reader done. After that, the next part comes as mapper. So you got the key value pairs from the record reader, right? So now the mapper basically processes the each pair and outputs zero or more new key value pairs. Next one is combiner. That is the optional, but it acts as a mini reducer thing actually to group mapper output and reduce the data transfer before shuffling. And next is partitioner. Partitioner assigns the key value pairs to the reducers. Okay, so it actually just bridging the gaps between the map and reduce task components. Okay, so it assigns the key value pairs to the reducers using the key dot hash code. Okay, something like that. Like you will have like hash code modulo operations with your number of reducers. So like this, like it basically assigns the key value pairs. You will have this, right? Like keys key dot hash code Okay, some key dot hash code function, then modulo number of readers, number of reducers. Okay, so with the help of that, actually, this partitioner helps to assign the key value pair to the reducers. Okay, next one is reducer, like reduce task components. So the first one is shuffle and sort. So it transfers the intermediate key value pairs from mappers to reducers. So this partitioner, like basically this partitioner and shuffle and sort, these two actually bridging the gaps. So partitioner took the responsibility from the mapping components, and from the reducing task components, shuffle and sort actually taking the responsibility. So it transfers the intermediate key value pairs from mappers to reducers, and after that sorts them via those keys. Okay, and shuffling begins as soon as some mappers finish. Okay, so next is reducer. So reducer what does, like it processes the grouped key value pairs and performing tasks like aggregations or filtering based on logic. Okay, so in this way, basically from the grouped key value pairs, it do the tasks. Okay, next is output format. So it basically writes the ultimate final results to HDFS. Like when you like the all the reducing operations done, then you got the output. Then in some file like HD in the HDFS, the result will be written, right? So through the record writer, it basically writes the output to the HDFS. Okay, so that's the thing. After that, let's discuss with HDFS. So HDFS basically the one file system for your storage purpose, right? So now you can use like other cloud storage like Amazon S3 and other services as well for other cloud components. But HDFS is one standard one, so you can use that one as well with the proper MapReduce. Otherwise, with the Apache Spark also you can use. Okay, so this is the file system. So that's the primary storage system of Hadoop. So like it built for mainly high throughput access to large data sets. So it runs on inexpensive commodity hardware and stores data in large blocks to optimize the performance. Okay, so HDFS basically ensures mainly the fault tolerance and high availability across the clusters. So data will be available properly. Okay, so it basically trust with two nodes. One is the name node, and another is data nodes. So these are the architecture components. Okay, so name node is the master node. So from that, one can ask you about the master slave architecture. So when one will you ask you about the master slave architecture, you can give the example of the HDFS. Okay, so the master node is basically in HDFS that stores the metadata, not the actual data, and it manages the file operations and directs the clients to nearest data node for efficient access. Okay, you have reached one to one malls. Okay, there are some peoples, okay, who actually know about all the shops in a mall. So like you will ask them, so they will refer some uh, shops. So you can think like that. So those are the masters or the owner of that mall, and whatever shops owner, so those are the data nodes. Okay, so now this is the data node. Data node is known as the slave node. Okay, so what slave nodes does, so it basically stores the actual data blocks. So like I have told you, right, the owner of the malls doesn't keep the actual things what you want to buy, right? They are the owner of the mall. So in the mall, so multiple shops are there. Okay, so they have the address of those shops. Like this shop is in the second floor, this shop in the third floor, like that. So in the same way, name node will have the addresses or indexes, something like that. You can think. So those are the metadata. So they can relate the where in which floor those are there. So the owner already tells you like if you want to buy the mobile, then this Apple store is in the third floor. Okay, so that you got like that information you got from that owner. So that information you in the same way you will get from the name node. Then you will reach to the third floor and you will find out the your Apple store, right? So that Apple store will be the data node. It is at the slave node. It will have the proper data. So it will have the actual data. Okay, so it stores the actual data blocks and serves the read write requests. So in the same way, they are in the Apple Store also. The buying and selling of the Apple phones or MacBook, those things will be covered. So, right. So in the same way, here also the actual data blocks are the data nodes. Like actual data block stored will be done in the data node and serves the read write request and reports to the name node. Okay, and supports the replication. So what is the replication? That also I've told you. So like for fault tolerance purpose, like right, HDFS is mainly for the fault tolerance. That's why we use the HDFS. That's why we prefer the HDFS. So how the fault tolerance are happening? So fault tolerance mainly happening via supporting the replications of this HDFS through the data node. So it supports the replication. Default is 3. So that's why how the fault tolerance and scaling of the storage and performance with more nodes happened. Okay. Now the next thing is like the high level architecture of Hadoop. The file block is the more important part. Okay. So what file block does? Just a second. Here this picture is relevant. Hmm. So file blocks in HDFS, what it does. So hi everyone. So actually I have now added the correct picture for the file blocks, right? So what the file blocks, like what is the concept for the file blocks that I will discuss mainly here. So in HDFS, data is always stored in the form of blocks, right? So these are the blocks. This one block, this another block, this another block. Okay, so when by default each block is 128 MB, okay, in size. So although this value can be manually configured depending on the use cases, like commonly increased to 256 MB or more in modern systems, but by default it is 128 MB. So you can see the data blocks in Hadoop HDFS. Like if you will have the 400 MB, suppose you uploaded a file with 400 MB to HDFS, then Hadoop will divide this file into blocks. Okay, like 120 MB A block, 120 MB another B block, and 128 MB C block. Then the left is 16 MB that will be in the D block. So this creates four blocks, three of 128 MBs and one of 16 MBs. So Hadoop splits the file purely by size, not content. So a single record can span across two blocks. Okay, so if you want to compare with a traditional file system, so then you will get the point about this block size efficiency. So how this is happening? So in traditional file system, we use the small blocks like 4 KB, right? While HDFS uses large blocks, which is 120 MB plus, so 120 MB more, or more than that. So large blocks in HDFS reduce the metadata and IO overhead. So in that way, like as it is reducing the metadata and IO overhead, so it improves the scalability and efficiency for big data processing. Next is fault tolerant replications that I have also discussed. Like for the replication in HDFS, it increases the fault tolerance. So HDFS replication ensures data availability and fault tolerance by storing multiple copies of each block. So by default, the default replication factor is 3. Okay, so but it is configurable in HDFS site. XML file is there. There you can configure that one. But usually it is actually 3. But if a file is split into 4 blocks with a replication factor of 3, then 4 blocks multiplied by 3 replicas. Okay, like if you will have the 4 blocks, you can see here, right? There are 4 blocks. It is there. So if for each block 3 replications, then total 12 total blocks will be created. Okay, 4 multiplied by 3. Okay, so so it designed for commodity hardware, so where failures are common. So replication prevents the data loss while it increases storage usage, reliability, or some priorities over space efficiency. So for that, it is good. Next, I can say about the rack awareness optimization. So like a rack is a group of machines, typically 30 to 40 machines, okay, in a Hadoop cluster. So large clusters have many racks. Racks awareness helps the name node for like choosing the nearest data node for faster read write operations. Like what I have told you. Suppose in the mall, okay. Now in the mall there are suppose 5 floors. Okay, so like in this fifth floor, one Apple store is there. In third floor also Apple store is there. So now if you are and in fifth floor, one cinema hall is also there. Okay, now if you went to see a movie in the fifth floor. Okay, now if you will ask like where I will buy the iPhone, then the easily accessible means in the fifth floor also one Apple store is there, so from there you can buy. But suppose you just reached to the mall. Okay, now you are at the ground floor. Now you want to buy, then will you go to the fifth floor? No, like through the lift or by some you can you will reach to third floor. Okay, by lift or escalator you can reach to third floor, and from this third floor you will buy that iPhone, right? So that's the case actually. So that's why rack awareness is more preferable. Like rack awareness is very much important for the name node. Like it will choose the nearest data node for faster read and write operations. So it will reduce the network traffic by minimizing the inter-rack data transfer. Okay, so that I have also discussed. Now next part is yarn, yet another resource negotiator. So that is basically the resource management layer in Hadoop. Okay, so it allows multiple data processing engines like uh, suppose MapReduce is there. These are the data processing engines. Okay, now Spark. Okay, so in this way it will allow multiple data processing engines and like your MapReduce, Spark, and others also to run and share the cluster resources efficiently. Now it handles two core responsibilities. First one is job scheduling, second one is resource management. So like it splits the large task into smaller jobs and assigns them to nodes and manage the priorities, and according to the priorities it will and dependencies it will execute those tasks. So in this way it will help for job scheduling. Next is resource management. So it allocates and monitors the cluster resources. What are the cluster resources? CPU, memories, etc. So whatever cluster resources, so it in that way needed for the job execution. In that way, it will manage the resources. Okay. Now next is components of Yarn. So first one is resource manager. So master node that manages the global resource allocation, that is the resource manager. Then the node manager. So node manager basically the slave node means the name nodes. Sorry, data nodes. Data nodes are the slave nodes, right? Name node is the master node. So master node is the like the name node is the resource manager, and node manager means the data nodes are the node manager. So slave node that monitors resources on individual nodes. Okay. Now application master, it manages the life cycle of each individual application or job. Okay. So what are the key functions we have discussed? So like multi-tenancy, like it supports the multiple users and applications, then efficiently it efficiently scales to handle thousands of nodes and jobs. In that way it will help for the scalability. Then it will also maximize the resource usage across the cluster, so it helps for better cluster utilization. Next is like it also works with MapReduce, also with Spark and other data processing models. Okay, so in that way Yarn helps for the compatibility, so like it will be dynamic. Okay, now next is Hadoop common. Common utilities will be there. So like Hadoop common, also known as the common utilities basically. So it includes the core Java libraries, scripts required by all the components in a Hadoop ecosystem, such as HDFS, Yarn, and MapReduce. So These libraries offer core functionalities such as file system and IO operations, then configurations and logging. Next, security authentication, then network communication. So Hadoop Common provides shared libraries and utilities that help all the Hadoop components work together. So it handles hardware failures automatically and includes tools like Hadoop Archive, native library support, and other RPC mechanisms. Okay, so this is the funda of the Hadoop architecture. I hope this video will be helpful for your upcoming interviews and all, or building some concepts. Okay, so that's all for now. Thanks for watching the video. Do like, share, and subscribe to motivate me. Okay, next lecture we will discuss another thing. Bye.